So what I want to show you guys here is the process and how this is all begins, okay? Oh, everybody's coming in, huh?
Yes, sir.
Okay. Influence. Primary. These are primaries, okay? This is going to be solids going over to the primary digester. This is going to be what's called, that looks like mixed liquor. And this is going to be the effluent, secondary effluent. And this is going to be RAS and WAS. What's the difference?
One is return.
All right. This is the waste one because it's going to the solids building. This is the WAS because it's main RAS because it's going back to the AB, aeration basins. Okay, so off of that, off of the secondary clarifiers, it's going to get my effluent. This is the final product going out to the river. This is solids that go to the digester. First digester, 19 days in there, polishing. This is going to the fields. Okay?
So it's Class B.
Class B. Any questions on how this process is going to work? So first, we'll go to solids building, see fine screenings. Then we'll go to see the primary clarifiers. Off of that, actually, here's a better sample of it. Waste directly to the digester. Okay, and the top part's going to look just like this, going to the aeration basins. Aeration basins over to secondary clarifiers. Off the secondary clarifiers, RAS and
Was.
okay. One's going to get wasted, one's going to help the buds do their job all over again. To the rivers, to the digesters. Okay? Amazing what effluent does. All around with effluent. Okay, over here he's doing respiration rates, celometer, VSR. This plant is activated sludge class 4. It's only manned 8 hours a day. I have a SCADA system here that's telling me what's going on in the plant completely. It will call out if there's any problems, but I can monitor the plant basically all from here. Here's the wet well, influent pump station, primary clarifiers, secondary. These are the aeration basins. The blowers tell me how much DO I have out there in each section, each cell. Post treatment.
Aeration basins?
Correct.
How many blowers?
I have a total of 3 blowers, but I'm only running on right now, I believe 1. I believe in on. Let's see where I'm at. Let's see. Blowers. We're running on just 1 blower right now. And these are K-turbo blowers, airless blowers. These have been put in for maybe 2 years now.
What's the horsepower?
I don't know, about 200. They're running right now at what, 20? How many fast? Right, they're turning right now at 2,500 RPM. So these things are just really spinning really fast.
You usually only use one blower?
Depends on how much air I need, but for right now, for this time of year, yes, just 1. And I'm running on all 4 aeration basins.
And just that one. You're doing all 4.
I'll take it down and show it to you.
Aeration basins. Okay. So how long is total detention time?
Total detention time. Interesting question. About, let's see. I'll do a spreadsheet for you. I'll do a spreadsheet. It's on the monthly workbook right now. So my spreadsheet, it's going to be, I say about 12 hours. Let's see. It's really nice about this because everything is calculated out for you. You don't have to use that calculator like they're doing. No. Computer does it all for you now.
You said it was the SCADA system?
This part over here is, this here is just my regular computers that have all my lab data, limbs. This is the information I got back from the lab today, how my plant's been running all week. Mixed liquor, RAS, TSS, BODs, E. coli, everything right there, ammonia. My limit right now is, I think, 24, 25. You want to know about the detention time. It's right, detention time right there. Aeration basin detention time right now is 6.4. Secondary clarifiers in there for 6.7. The total secondary system 13.1. It's already calculated out there for us, so the way to go. And right now I'm running out about a 41% return rate from my clarifiers back over to the aeration basins.
21%?
41.
41% RAS?
That's
Yeah,
return
rate right now is at 40. I got it set for 40, I believe. I know it's set for 40. RAS control tuning, 40.
How often do you have to test for E. coli?
I test 3 days a week.
Same as us.
Yep, Monday, Tuesday, Wednesday. And that's it. Okay, any more questions?
You're doing good.
Okay, let's go outside and see the plant then. Let's see. I have 77,800 people units on this line coming into this plant. And our maximum, let's see, dry weather flow 7. Wet weather flow, we're rated at about 10.2.
Do you have a lot of I&I problems here?
No, not really, because a lot it's split. See, we're a system now. Part of my flow goes to the other plant, the Tri-Cities plant, and then a lot of it comes here. I treat all Milwaukee, but things on the other side of 205 goes to the other plant now. So they keep this plant limited at the high flow, maybe 16. So I shouldn't have any more violations. But you know, secondary clarifiers, aeration basins, primaries, everything's hydraulic. 48-inch line. I got a line coming in, the Kellogg interceptor line, and they're all meeting right at that box right there. There's a big box right there where all the lines, where all the water's coming in.
You said a line comes in from Milwaukee, where
Milwaukee, coming down from Milwaukee, the other one's Kellogg Creek, and they actually put a line, a sewer line, way back when things were not so down in Kellogg Creek. That's the wet well. That in there is the wet well. We go in there once a year. The water is coming in there, and 10,000 gallons a minute supposedly. Per pump. Except for the little one, I'm bringing it out to 6.
Updates us.
Here we have the, of course, influence sampler. That's it. Now you're in those thinking. Bar screens. They're automatic bar screens. When the level comes up in that channel, when enough debris gets on the screens, I don't know if you can see them in there. That rake will automatically come down and scrape it all off and put it in here. It's compacted through there and dumped into what's called a grit trailer. This right here is what's called a detriter, where the fines, like the heavy solids are settling out in the bottom of this. It's just like a bowl, and that's the squeeze arm going around. It looks exactly like this in a clarifier. Same principle. If the heavies are settling out, there's 20,000 is going over there. Not now. 20,000 is going off of those primary clarifiers today over to that primary clarifier to be cooked. Okay?
Be what?
that's the heavy stuff.
Well, that's the solids.
Solids.
Yeah, the
Pounds, not gallons.
pounds.
Okay, yeah, pounds per day. All right.
Okay?
All right.
Okay, on down. Which way you want to go?
Where does
Let's go back that way.
What is this?
These are gates. These are just the gates that control the flow to each one of these clarifiers. So if I close this gate, no flow goes to that
So
clarifier.
this is like a big valve.
Yeah, it's a big gate. It's a big gate. It's a slide gate. These are slide gates. Actually, this one is going to go offline probably next week. So here are the primary clarifiers.
There's two of those.
There's two. Everything's just sinking to the bottom. You're standing over the primary pump station
And they're
right now.
covered.
Covered.
Okay.
For odor control.
And they're confined space.
So right here, you're standing on the primary pump station. You hear them, they're air controlled. Right? And like I say, I'm taking out. Here's your blower building. So the effluent off of these primary clarifiers going over here to the ABs. Aeration basins.
How many aeration basins do you have?
4. And what I run is what's called an oxic zone. I have 2 oxic zones. Anoxic zones. So there's a zone right here, no air. I got another zone right there, no air. And from there on, I'm giving it a bunch of air. I'm running right at about.
How many other zones?
Count them. 1, 2, 3, 4.
4 aerobic zones.
No. No, aerobic. Yeah, there's 4 aerobic. 2 anoxic.
Okay.
Is that why these are covered?
Yeah. Well, they're covered because
Both.
Odor.
Is that the start of the bugs?
no, the odor. What do you mean?
Oh, the anox
Just a-
zones are for the odor?
For odor and to make the
A different kind of bugs.
bugs eat that before, because when the bugs come in, they're really hungry. So you just want them to eat everything that they can, because if you, I don't want to go, I don't want to get filaments. It's for filament control is what that's all about. Why I run it this way, which seems to work. It's worked out for worked. You want to see what a blower looks like?
Absolutely.
But a serious, now these are serious blowers. This is the new technology when it comes to blowers. These are what's called airless blowers. Airless because it doesn't airless bearings.
So it floats?
Yeah. I mean, this like it's turning at. Oh, that one's not on, but it's turning at 25. This is the standard old type blower. The low. These are the old things. We have just one of them just for looks, I believe. Yeah. I believe it.
Probably easier to keep it in here than take it out.
That one's not running. At 25 RPM, there's 3,000 CFIs going out there for the air. Been running 700 hours. I mean, it's the way to go. The air pressure is only, that's the filter pressure. But you see how hot the air is though. Air going out there is very warm, 150, 152. So here it's anoxic. Now you got your air going here. These got the most going to them. I think it's at 5, I believe. I believe that's the set point on these. Water's coming, let's see, how does that work? Water's coming over the top of the wall, being pushed down, comes underneath this wall, and back over, so it's doing a, then from here on out, just straight on through. And this is out in this section. This section here is 1.58 on the air, and this one is what? 1.4. So see? So as you do this, you know, you want most of your air up front. And as it goes through, you want it to drop off. You know what you're talking about.
In the aerobic zone.
Yeah, and anaerobic, aerobic. And see, it's dropped down a little bit. 1.3. This one's here about the same.
So what type of aerators do you have under there?
These are coarse bubbler diffusers. And let's see, now look at that. Our aerations dropped down to 0.55 and 8.9, so we really dropped off on our air. Because I don't like to carry air over to the secondary clarifiers. All your work should be done here, not over there. So that's why I do not try to carry air over that far.
See the algae.
Yeah. How I control that is, I said we have sodium sulfite here, and so when I have a tank back there, I take this offline and I spray this down with that bleach, and it'll take that right off. I've only done it one time because this year so far because it's been so wet. But we'll probably get to it next week, and that'll be completely cured. Yeah. What else am I going to do with that sodium, with that chlorine? You know, it's just sits there, so we found a way to use it. So we made up this, and what we did, we just took some little pumps there for like a carpet cleaner, and we took that pump, and we took some plastic tubing that runs all the way around there, and we just stamp with a wand here and spray it on here, and it takes care of it. Oh yeah, that what's one of the rivers?
Yeah.
Do you, when you clean it, do you use the 12.5%? Do you dilute it down?
No, I don't dilute it. It's already diluted.
Oh, is it? Okay.
Because we just tested it the other day and said 11.5 right now.
Just for not being used.
Just because it's just sitting there, so why waste it? So we found another way to use it. Correct. Sodium bisulfite to diesel. See, I know I'm changing right now because now I got scum coming up. So I know that it's time for me to make an adjustment. It's getting old on me. But I'm starting to get these floating things coming up. So I'll either...
The nitrification or the bullshit?
Well, the weather's getting warmer, colder, warmer. Just things just going back and forth. So do I waste more or not? Or do I increase my RAS return rate, take more out of here and put back over there, still waste some of it out? I don't know yet. It's getting to be that time of year, so. Okay, this plant here disinfects with UV. One of the first plants that actually did it out here on the West Coast. But I do have a backup system, which is chlorine, which I have liquid sodium hypochlorite, which I hate. The UV system is really good. This is all getting ready to get rebuilt again. There's 1,564 lamps. Chlorine contact chamber, UV. Each channel can handle 12.5 million gallons. It's rated at, okay? But I have both of them on right now because it was supposed to really rain, which it did. I clean these lights every 2 weeks just to make sure that we don't have a E. coli excursion. I dip them in a tank over here. I have a tank over here that has phosphoric acid. This is a bad time of year once it starts getting like this warm, when it goes from the cold to the getting really warm like it is. This is when it's hard to run the wastewater plant. But then you got to find this weak spot again. So same thing when it switches from summer to fall. Other than that, so there's your effluent, and the outfall was right there going out by the bush back there going to the Willamette River. But that's it. That's right before it goes through disinfection. This is coming off the secondary clarifiers.
It's cleaner than the river.
Yes, I've done that before. I've taken the sample, and yes, this is cleaner than the Willamette River. Right now, maybe at 3.
Primary's covered.
Why are they covered?
Is it from the algae to the algae?
No, odor control.
Odor control, okay.
You know, water is very versatile. It does all kind of things, you know. And one thing it does do, it carries odors. You know, so
It's not very ridiculous.
that's because everything's covered. I'll show you the biofilter.
So to get in that, do you need a confined space entry
That's a
permit?
confined space.
Okay.
So these are just biofilters. You know, because another part of treating water is the smell. So this is how we treat it. Yeah. So what it is we have I think 6 of them. And what we do, we just blow. There's just a bunch of tubes underneath here, and we just blow the air up through here. And then I'm gonna wet this. I'm gonna spray this down with water. You can see the sprinklers heads around it. So when it gets too dry, because this is another biological process. So the bugs eat the bugs do the work for the wastewater. Well, the bugs also do the work for treating air. So there's water underneath there, and then you got to spray the water on top. But you know, since it's been raining, we haven't had to do that. But now it's time to put the sprinklers back on it.
So this is just called a biofilter.
And this is common practice now. From this building here is the thickener building. What this is going to get is all the stuff, the solids, off the bottom of the secondary clarifiers, which is going to be the waste. The WAS is going right here.
Right.
Okay, WAS is going in this building. Crap. This is off the secondary clarifier, the very bottom. And what I do here, I just add a whole bunch of air to this and some polymer, and I make it float. That blanket is probably 6 inches.
This is all waste. This is all going to waste this landfill eventually, right?
Well, now this is going to the digester. After I spray it off, that is effluent off of the rotary drum. That's the pressate off of the rotary drum. See it getting thicker and thicker and thicker.
Oh.
Thicker and thicker and thicker, and then it's landing into the pit.
So the water goes that way and the solids go that way.
If the water is being recycled back through the plant again, that's what you call a waste stream, you know, so you're adding water to your plant. This is what's called a rotary drum. Turning really, really slow. I think I'm adding maybe 40 gallons a minute if that to this right now. Like I said, the primary digester is the one that's doing all the work. Okay, so in order I have to transfer from that primary digester to the digester that we're hauling to the field. Well, to do that, I run it through this rotary drum to take some of the water out and make it thicker. So I just don't transfer between digesters. So that's what the rotary drum is doing, is just making it thicker. So you're not hauling water to the field.
So the water's going back to the primary clarifier.
It's going back to the plant. Actually, it goes back to the headworks. It goes all the way through the whole process all over again. Which adds ammonia to your plant, so you got to always watch out for the ammonia, because we all have an ammonia limit, so you don't want to bust that. 20,000 pounds were going over that digester. And then on the wasted, when I do the WAS, the wasted, I use 15,000 is going to that digester per day. So right at what, 60,000, something like that, pounds go over there every day. Here's our digesters. These came well, this is probably the newest part of the plant, actually. These came back in, what, 1980? It used to be, they used to use that holding tank right there to haul to the city of Portland.
What's the capacity of those puppies?
These are 1 million each. You want to go inside there?
Absolutely.
This too.
1 million each.
1 million each. And that's the primary, one doing all the work, staying in there for maybe 19 days. Then I'm slowly transferring through that rotary drum back over to this digester, and it sits in here for maybe another 19 days, if that. Depends on how fast they want to haul out of here. It's overflowed a few times. It's not fun. No, not fun at all.
Did he say?
Oh yeah, it's overflowed before. Because you know, you get them upset. It's just like your tummy. If you get it upset, it foams. You know, so you add like Pepto-Bismol or something to it.
What is it that causes it to foam? Is it because
Is it a die-off of a...
I mean, there's
Filter.
It depends. Like if you get the cardia, you know, how do you get rid of that? You pump it to your digester, make it upset. So it just depends. That's what we get gas is. We get a lot of methane gas. So these digesters are heated with this engine generator, which is co-generating. It's got a big motor on the big generator on the back of it. So we're putting electricity back into the grid. Plus we're powering the plant.
Through the methane?
Yeah.
Oh, very nice.
All methane. And that right there is the flare. If there's too much fuel, if we can't burn all the methane that we produce, it's burned right there. The question was gas detection. It's right there. You know if there's going to be too much. I have seen it hydro. Get out, get out, get out. What this is a tugboat engine. It's a big old tugboat engine is what it is. It's a 16-cylinder tugboat engine, which is burning the methane off of these two digesters. So that's what's heating it. You see the loop right here. For extra heat, we use a boiler right here. You see it's not running right now, so.
Oh, so it's...
Does that make sense?
Yes.
So that's how you run it. All the orange lines are the hot water coming off of that engine generator upstairs, and it's being mixed through these heat exchangers right here to heat the digesters. Digesters are probably running right now about 98 degrees. These are nothing but big old Campbell soup cookers. Just they're in a big heat exchanger. That's what they are. This pump is on right now. This is the pump that's feeding that rotary drum. By pushing from here, then there's more pumps over the salt split going that push back. We didn't